Hello, everyone. Today's video is on the greenhouse effect and climate change. The learning outcomes of today's video are to explain what the greenhouse effect is. We're going to define climate and climate change. Then we're going to look at how greenhouse gases are impacting our climate. So to get us started here, the greenhouse effect is sort of the principle that composes our atmosphere. This is something that's ultimately good and beneficial for life on Earth. Our ability to retain an atmosphere is something that allows us to live at temperatures that are more conducive and easier than the harsh temperature changes that are found in space and on planets that don't have atmospheres. So what's happening is heat is being trapped by the gases. So air may seem empty to you. There's nothing to feel, but it's actually composed of a lot of atmospheric gases, nitrogen, oxygen, carbon dioxide. As you move up into different layers of the atmosphere, you get more ozone. In these gases, when they are exposed to heat, they'll trap some of that heat in instead of allowing it to simply go away. It's stored in those gases in chemical bonds, and so that energy sticks around for a little bit longer. Um, this is akin to a greenhouse. So people set up greenhouses around their plants in places that are really cold because heat passes through the glass. It's able to expose itself to the leaves of your plants. They're able to get some sunlight, and then it heats that air in the greenhouse, and that air is stuck there. It doesn't go away. And so thus that heat gets trapped by the glass of your greenhouse. The infrared is able to pass through, but the heat, the sunlight, that energy that sticks around um, is good for your plants as well. They need sunlight, but they also need to be warm in order to photosynthesize. Um, and so that is what composes our atmosphere, this greenhouse effect. And the climate, people usually mistake climate for more like short-term weather conditions. Like today, it's very sunny out. Yesterday, it was cloudy out. Those are not climate. Climate is a long-term temperature and weather conditions of an area. So in California, in the Santa Cruz area, we live in a Mediterranean climate because long-term, we're being exposed to more temperate weather. It does not freeze in this area ever. And so then there's lots of heat, there's lots of sunlight, and everything stays pretty moderate, which is akin to a Mediterranean environment like that you would find in Italy or other countries on the Mediterranean Ocean. And so this is something that is impacted by the greenhouse effect actually being caused by these atmospheric conditions in your area cause the climate in your area. And so it's been found that we're increasing in greenhouse gases. These gases like carbon dioxide is a very popular one you hear about. Methane is a greenhouse gas. Water vapor is actually a greenhouse gas. We're not doing anything to impact the concentration of water vapor in the atmosphere. That's staying pretty constant because when the atmosphere gets a lot of water vapor in it, it precipitates. It's a self-regulating system. Whereas with CO2, so here we have atmospheric CO2 in parts per million. So that is a microgram per meter cubed of air. Um, when you have a part per million of gas, um, that is a concentration. And so the concentration of CO2 in the atmosphere has been increasing steadily ever since um, the Industrial Revolution in around the 1880s. And so here we have that associated with the temperature anomaly. And so this is the temperature of that year subtracted from the mean temperature from, I believe, the years 1950 to 1960. And so, as you can see lately, as populations grow, as industry grows, we're seeing an extreme increase in the temperature anomaly and the height at which the temperature extremes are getting. And that is correlated with a highest concentration of atmospheric CO2 on Earth that has ever been recorded, even in temperature cores that go back thousands and thousands of years. You're able to go to the Arctic, drill these ice cores that include gases in them that were preserved there at concentrations that existed in the period where that water was deposed there. So what that means is you're able to drill down, and as you move down the layers of the ice core, you can extract the concentration of gases at each level, each layer of that ice core. The deeper you go down, the further into the past you go, and you can actually extract previous carbon dioxide concentrations alternating between around 280 and 200 parts per million. So we're now at 420 parts per million, so much higher than that. It's also associating that with methane. Methane is another greenhouse gas common in, uh, you know, biological respiration and biological systems, and then correlating that with the temperature change observed during that period as well. And so that concludes our video for today. Thank you and take care.